All right. So for our last video, we actually need to talk about precipitates. Now, before we get too far into what precipitates or kind of going through this process, a precipitate is just a solid that's produced when you mix two substances together. So when this happens, we would have, let's just say, something like salt water. So salt dissolved in water. And then we have this other substance that's also dissolved in water. Now, when we mix them together, what happens is part of the products, one of the products is still dissolved in water, but the other product actually starts to form a solid. And so when this happens, we generated or we created a precipitate. Now, a couple important things to know about precipitates. First, precipitates are what we consider insoluble, basically meaning if something is insoluble, it's a solid, meaning it doesn't dissolve in water. So anything that's considered insoluble is, well, a solid when it's thrown in water. And so there's tons and tons of substances, but there's also tons of substances that dissolve in water. In fact, a majority of ionic substances dissolve in water. So there are some, however, that we're going to talk about that don't. And so what we're going to talk about today is predicting when something will be a solid, when it won't be, or if you make one, how to figure out which of those two substances is your solid. Now, if insoluble is our solid, that means soluble is our aqueous solution. So soluble means it dissolves in water. And so I kind of pointed it out already, or I said it already, but that means that this is the thing that's aqueous, or it's an aqueous solution. Now, aside from that, a little while ago, we talked about important symbols. Two of them were AQ and S. And so let's just kind of label those again. So AQ, remember, stands for aqueous, meaning this dissolves or it's soluble. And then we have S, which stands for our solid. And we write these, and this obviously doesn't dissolve, so we can label that doesn't dissolve. Or this is our insoluble substance. All right, so now that we kind of have these terms defined, let's talk about our solubility rules. Now, our solubility rules, yes, they're here, but they're also on the back of your periodic table. Now, I know I told you guys a bunch of stuff about what you'll have to memorize and stuff like that. Now, the solubility rules are something that you will not have to memorize. You will always have access to these rules. So when you need them, they're there for you to use them. Now, let's kind of go through and start looking at some examples. And so before we look at how it works with reactions, let's just look at it in terms of figuring out whether something is soluble or insoluble. So our first question is KCl soluble in water? Now, for our solubility rules, notice there's these two. Now, these two are the only two that relate to cations. The rest of these all relate to anions. Now, I think it's a whole lot easier if you just look at the anions the entire time, as opposed to kind of trying to flip back and forth and figure out which rules to use. So if we're only going to look at the rules according to the anions, when we're asked, is KCl soluble in water, we're looking at the chlorine or the chloride. So now let's kind of go through and compounds containing, and let's find chloride in our list. Oh, here it is, chloride. So the way we read this is compounds containing chloride generally are soluble. Exceptions include those of lead, silver, mercury. So that means that it's basically saying chloride compounds are soluble with these three exceptions, which means that is KCl soluble in water? Yes, because potassium, or the K, is not lead, silver, or mercury. Okay, let's look at another one. Is AgCl soluble in water? Well, if we follow the same rule, let's look at the chlorine or the chloride rule. So chlorides are generally soluble except lead, silver, and mercury. Now, Ag happens to be silver. So in this case, the answer is no. AgCl is not soluble in water. Okay, well, let's look at some other examples. How about KOH, soluble in water? So we look at our hydroxides. So compounds containing hydroxide are generally insoluble. Exceptions include ammonium, alkali metals, calcium, strontium, barium. Oh, but wait, is potassium one of our alkali metals? It is. So everything in that first column or group 1 is an alkali metal, meaning it's the +1 group that we've been using for naming. So that does mean that since hydroxides are insoluble, except with the alkali metals, because KOH is an alkali metal, that does mean, yes, it's soluble in water, because it's the opposite of insoluble, which remember means solid. All right, let's look at another one. How about CaO? Ooh. And you know what? Let's actually change this one. Let's say it's CaS. Instead. So if we have CaS, as we're looking at this, so we look at the anion, so sulfide, and let's find our sulfide rule. So compounds containing, oh, here it is, sulfide, generally are insoluble. Exceptions include ammonium, alkali metals, and the alkaline earth metals. Okay, so now let's kind of double check. Is calcium an alkaline earth metal? And yes, it is, because the alkaline earth metals are group 2. So yes, this would happen to be soluble, because remember it's saying sulfides are insoluble except that set. All right, let's look at one more example here before we move on to looking at it for reactions. And we have, is SrSO4 soluble in water? So let's look at SO4, which is sulfate. And let's find it in our list here. So it says compounds containing sulfate generally are soluble except lead, silver, mercury, calcium, strontium, and barium. So strontium is listed as one of those exceptions, which means it's not soluble. It's the opposite of soluble, as insoluble. So this is no. All right, so that's it for this part. Now let's look at how it relates to figuring out reactions. And so as we're looking at reactions, we have a couple steps. The first step is to always write the reactants with AQ after the formulas. Now this part is important because when we're making or predicting precipitates, the reactants, meaning the first part or the left side of the arrow, reactants are always aqueous. So that's something that you guys should know. It's a time saver. You don't even have to check. They're always aqueous. Then after that, we have predict the products and write out those formulas. Now, after we have the formulas, we use the solubility rules to determine which substance is insoluble. And this substance is the precipitate. Then, after we figured out which one is the precipitate, you add the S after your precipitate and AQ after your other product. Now, on a kind of side note here, not all reactions produce precipitates. And so this is an important point, because if you get used to the idea that you checked the first one, it wasn't a precipitate, you checked the second one, and it ended up not or being a precipitate, you're going to get used to this idea that you only have to check one and not the other. And that just isn't the case. And so you do need to check both products. So just kind of something to keep in mind as we're kind of going through these. Now, obviously in these notes, everything's going to be a precipitate, but like I said, that's not always the case. And in fact, on the worksheet or the practice that you guys have, That's not the case. You don't always have precipitates. Anyways, let's get into our first reaction here. So we have Ki plus PbNO3 2. So with predicting our products, the Pb and the K are going to switch spots. So we're going to have first potassium nitrate. And yes, we can say it, but let's look at some charges here. So potassium should be +1. NO3, one of our polyatomic ions, we've seen it a lot, is -1. So it's going to be KNO3 plus, and now let's look at our other product, which is going to be Pb now bonded with I. Now, we do need to figure out what lead's charge is. Now, to do that, let's kind of reverse or look at our PbNO3 2 compound, and we can figure it out that way. So if we know nitrate is -1, here, when we have this 2, the idea is if it's 2 minus 1 charges, that means that the total negative charge is -2, which means that if there's only one lead, the lead has to be +2. Okay, so lead's charge is +2. And then it's paired up with iodine. Now, for iodine, we know because of where it is on the periodic table, it should be -1. So that means that this formula should be PbI2. All right, so now that we have these listed, now let's kind of go through and figure out which one is our aqueous versus our S. And so let's start off with our KNO3. Oh, remember, step 1, we could write AQ after both of these. And here I'm going to erase all this other stuff because we don't actually need it there. So let's check KNO3. So potassium nitrate. And so now let's look at our list here and let's find where it says nitrates. So compounds containing nitrates, there it is, generally are soluble with no exceptions, which means KNO3 is soluble, so it gets the AQ. I know it's part of you wanted to write S because soluble S, right? But keep in mind it's opposite here. And then let's check PbI2. So I2 is lead iodide. So let's find iodide in our list here. And so as we're looking, it happens to be compounds containing, here it is, iodide. So generally are soluble except lead, silver, mercury. Oh, so lead is listed. So that does mean that lead is insoluble, or the lead iodide is insoluble, making it our solid. All right, so now that we did this, don't forget our last step, even though I know it wasn't there before, we can't move on without balancing. So don't forget to balance here. And so as we're balancing, let's start off with potassiums. Those are good. Iodines, we got 1 and we got 2 in our products. So we had a 2 here. All right, so that fixes iodines. Now leads, we got 1 and 1, that's great. Nitrates, we got 2 nitrates here. So that means we need to add a 2 over here. All right, and now that we balanced, now we're done and we can move on. All right, our next example, a little bit longer. It says cobalt 2 chloride and potassium hydroxide react. Predict the products, determine the precipitate, and write the full chemical reaction, including the states of matter. Then balance it. So that's like all of the steps for the entire thing. And that, if it helps, is exactly what we just did. And so first up, cobalt 2 chloride. Okay, so cobalt is CO. And then remember the 2 here tells us the charge of cobalt is +2. Then we have chloride, so Cl. And Cl has a charge of -1. All right, and let's just do all of our elements with their charges. Then next up, we got potassium hydroxide. So potassium is K with a +1 charge. Hydroxide is OH with a -1 charge. There it is. And so now let's go through and write out our substances with their correct compound formulas. So cobalt chloride, so CO and Cl. So it should be CoCl2 plus potassium hydroxide. And the +1 and -1 cancel, telling us it's just KOH. Now, as we go through, the CO or the cobalt and the potassium are going to switch. So now our first product would be cobalt with hydroxide. And so the +2 comes down, making it COOH2. Plus now the second part, it'd be potassium bonded with chlorine. So since those are +1 and -1, it's just KCl. All right, so now that we have our reaction, we predicted our products, let's do our precipitate part. Now remember, we can write AQ after both of our, I should have left a little bit more space there, both of our reactants. So let's start checking our products. So we have cobalt 2 hydroxide. So we check our hydroxides rule and see what it says about cobalt. And so as we're looking at our hydroxides rule, let's find hydroxide. There it is. So hydroxides are generally insoluble, except ammonium, alkali metals, calcium, strontium, barium. Oh, so cobalt isn't included, which means that our cobalt 2 hydroxide is insoluble. Now, if it's insoluble, remember that's the solid. So, so that's what gets the S here. And if we already figured that out, that means that KCl is automatically our aqueous compound. All right, so now that we've done that, our next question is circle the precipitate in the following reactions. So sometimes you have the reaction written, you just got to figure out what the precipitate is. Now remember, where does our precipitate form? As a product. So don't even check these. You don't need to. So don't check. Eliminate them, not options. All right, so let's first start off with AgCl. All right, so Ag is silver, Cl is chloride, so let's check our chlorides rule. And it says compounds containing, chloride, there it is, generally are soluble except, silver. So we've actually already seen this, because otherwise I probably would not have drawn so many lines over it. So there we go. That means our first one is AgCl. That's our precipitate. Now our next one, magnesium nitrate, so MgNO32. Let's check that. Now remember, since we already figured out AgCl was a precipitate, that's why we're done with the first one. There's only one precipitate in a reaction. So let's check magnesium nitrate. And so if we check our nitrates rule, where is it? Boom, there it is. Compounds containing nitrate generally are soluble with no exceptions. Okay, so it can't be the magnesium nitrate. How about the silver iodide, the other product, the AgI? So let's find it. There's our iodides rule, and it says they are generally soluble except, silver's there again. So that does mean the AgI is our other precipitate. All right, that's it for this video. I'll see you guys later.